So, welcome to the Get Me class. This is question number 1. An ideal solution has two components, A and B. If B is more volatile than A, and also P naught A is greater than the total pressure, PT, then the correct relationship between the mole fraction of A in liquid and the vapor phase is. Let's see the options. So the first option is A, that is chi A is equal to YA, or component mole fraction of A is equal to the component of the vapor pressure Y. Option B, XA is greater than YA. Option C, XA is smaller than YA. D, nothing can be said. Well, in this entire scenario, we are going to make use of two different concepts. That is the Rolle's law and the Dalton's law of partial pressures. So let's make use of these two. So therefore, according to, if we take into consideration of the Rolle's law, so according to the Rolle's law, so according to Rolle's law, the expression that we have is PA is equal to P naught of A into chi A, or the component mole fraction of A. While according to the Dalton's law, so according to the Dalton's law, we have over here, it is the partial pressure of A is equal to a product of total pressure into that of the component, okay, that is a mole fraction of the component in the gaseous phase. So let's take as YA. So for a moment, let's say that this is our equation 1 and this is the equation 2. So therefore, combining equation 1 and 2, combining equations 1 and 2, we have over here, that is P naught of A into XA, or you can call it as a chi A, is equal to PT into Y of A. So this is an expression what we will land up to, right? So now, from this entire case, what can be said is that the expression that they have already given a hint as P naught of A is greater than total pressure of the solution. So therefore, in this case, we can say that chi A, okay, as the component A, if we consider the hint, that is, if A is more volatile, okay, so here that is a statement, if A is more volatile than B, okay, then the correct relationship between the mole fraction of A in the liquid and in the vapor phase is. Now, if it is more volatile, it's quite considerable that the mole fraction of A is less in the liquid state. So therefore, however, chi A is going to show us the amount, the mole fraction in the liquid state, right? So therefore, XA is nothing more than the mole fraction of the component A in liquid state. Okay, as it is more volatile, then it is quite natural that chi of A is smaller. That is, the mole fraction of the component A is less in the liquid when we compare to that of in the gaseous or in the vapor phase. So therefore, it is smaller than YA. So therefore, we would end up having this particular expression here. So therefore, this is the correct answer. And therefore, here, the answer is the option C. Thank you.